So in today's session, we will be talking about monitoring technologies. And what we specifically will talk about, you can see on the slide. So first of all, I will give a very brief case example of sleep monitoring, basically as a teaser of today's topics. Then we have some student talks, two talks on wearables, one on wearables for external load measurement, wearables for internal load measurement. The third talk will be about smartphone lab, basically, so using your smartphone as a measuring device. And we will have the first very special guest talk on velocity-based training, and I'm really excited there. And this will be today's topics. So as a first case example, as you may have noticed or maybe I told you this before, I'm collecting some daily data. I'm using currently the Oura Ring, which is a device for activity tracking, but also has some sensors built in to collect heart rate data, for example. So this is a resting heart rate variability throughout my sleep cycles. So the average heart rate variability throughout the sleep. What you can see in the bar charts is daily recordings with the root mean square of successive differences there. The lines, the dotted lines, is a 7-day rolling average, so that we are able to track trends over time. So what we see from on a day-to-day basis, lots of ups and downs if we are using daily recordings, for example. And some weeks trends go up, some weeks trends go down. Also, there's a little bit of color coding in the background, depending on are the values above or below the average, for example, more or less, or above or below the normal day-to-day variability, but also depending on additional information. So for example, if I say I'm sick, if I say I drank too much alcohol, for example, there could already be a color coded to today's recording, for example. Same thing with heart rate data. So basically heart rate and heart rate variability is displayed. And if you remember last week, I was not too fit there. And what we saw is a very, very substantial drop in heart rate variability from the normal values, almost to as low as it can get. I'm sorry. And heart rate variability was also on average roughly above 80 beats per minute, which is substantially higher than it's usually are. And then we see a very nice recovery period afterwards, where values tend to go back to baseline, but it takes almost half a week to a week. So one potential opportunity of how we could use wearables to get some information to see when is something off and are we already back to baseline. Also, if we accumulate all the data, if we look at all the data points which have been coded non-sick compared to sick, we do see, for example, that sick has a little bit lower heart rate variability and a little bit higher heart rate data. Also, what these devices usually have in common, or what they also provide, is that, for example, they are very nice consumer apps, for example. So I took a screenshot of the typical display I see every morning. So for example, there's some data of sleep. Basically, the different colors is different sleep phases. And on Sunday, there was a little bit low sleep the day before our seminar, because I had to prepare some things. What we also see is the heart rate recordings throughout the night and some missing data in the middle, and also heart rate variability. And this average heart rate variability of roughly 40 to 50 is quite common for me. And when we then saw next day, Monday night, after I felt very, very sick, again, heart rate variability dropped dramatically. And we can also see this throughout the course of the night. Heart rate gets up and up and up. And this is why I had to go back to bed before seminar. And we can also track a little bit more into detail. So the devices, the apps are quite nice there to also provide some information. And as the last anecdote, a little bit similar thing also happened after vaccination. So first night after second shot, also heart rate variability dropped quite dramatically. Although I slept a couple more hours than I usually do, didn't help, but the response due to the vaccination disappeared also very quickly. So quite interesting that we do, or that we are able to track physiological responses quite nicely nowadays. I don't have to do anything except for wearing the ring all night, and that's it. So one small teaser for introducing the topics of wearables and applications. And now we will start with the first student talks. And I would prefer if we start with the talk on monitoring external load, because this is our theoretical model, the first aspect. Then we go to internal load, and then we go to the smartphone app or the smartphone lab. So we heard about different wearable technologies for monitoring external and internal load, and we also talked about some aspects of how we could use your smartphone potentially for facilitating monitoring or measurement in practice. Regarding the cost aspect, please keep in mind, yes, 100 euros or $100 may seem a little bit expensive, but compared to a couple of $1,000s for light cells, for measuring sprint time, for example, I think that's relatively low cost. So this perfectly fits to the next topic, velocity-based training. And why do we put this topic into today's session? I mean, some aspects were already clear at the moment, but as you can see on this very nice infographic from Adam Vigil, and I highly recommend that you also check out his website, because he has many great resources also on things working in Excel and Google Sheets for analysis, which we will be talking about in the future. But when we're talking about velocity-based training and measuring bar velocity, we always also talk about different wearable devices, as you can see here on the left side, and also about applications for potential use of measuring barbell velocity. And this is why we're talking about this topic today. And I'm very excited to have a very special guest, my colleague, Nicola Volk, who's presenting on velocity-based training. And I think he will do a way better job than any one of us. So make the stage for him to give us his presentation.